Integration by substitution. Here's 4 examples that might appear on the leaving cert. The first example, integrate sin x cos cubed x dx. Now we'd usually let u equal the highest powered term. This would be cos x. So du dx is equal to, differentiate this, minus sin x. So du will be equal to minus sin x dx. And minus du is equal to sin x dx. And we write it this way because in our original term we have sin x dx. So minus du is the replacement. So let's replace things. Cos cubed x is u cubed, and minus du instead of sin x dx. So integrate u cubed and just sub back in original thing, cos x instead of u. So it's minus cos x to the power of 4 divided by 4 plus c. That's the answer. Okay, here we have a second example of integration. Again, in this example, we're going to let u equal the divider. That's 3 plus x. So du dx would be equal to 1. The root of 3 is 0 and the root of x is 1. So du is equal to dx. So we can rewrite the original thing. The constant 6 can be taken outside if you wish, but we could leave it on top here if not. So this is 1 over u by du. And this looks like a straightforward integration. Now we still have our 6. The integral of 1 over u is natural log of u, and we add on our constant of integration. Now remember that u is 3 plus x, so we'll sub this back in. 6 times ln 3 plus x plus c. And here we have a third example. So we let u equal to our denominator, x squared minus 4x plus 29. We usually let the denominator be the substitution. Differentiate du dx, and it gives us 2x minus 4. Now we might, if you notice that first, you might notice the answer, because it's always the answer will be log of the bottom, but we'll continue with this method. So du is equal to 2x minus 4 dx. Our limits, first limit when we sub in 7 into our u expression, so it's 7 squared minus 4 sevenths plus 29, and that equals 50. And our second u limit is we sub in 2, so it's 2 squared minus 4 times 2 plus 29, and this works out to be 25. So we can rewrite our expression. So the limits are 50 and 25. 2x minus 4 dx is just du, and so we're 1 over u. So differentiate 1 over u, we get natural log of u between 50 and 25. We don't bother with the constant of integration because it's a definite integral. So it's natural log of 50 minus natural log of 25, and we should know we can write this as natural log of 50 divided by 25, which is the natural log of 2. And there's the solution to this example. Okay, we'll do one further example now. This time again we let u equal to the denominator. A little bit more complex this example. Du dx is straightforward. This is just equal to 1. So it follows du is equal to dx. But how can we rewrite x squared plus 2x plus 2 in terms of u? Well, if u is x plus 1, well then x is u minus 1. So let's, into the x squared plus 2x plus 2, let's sub in u minus 1, since this is our substituted value. Now just multiply this out. Square u minus 1. You get u squared minus 2u plus 1. Then we have plus 2u minus 2 plus 2. This neatens up nicely for us. And we see we're left with just u squared plus 1. And we do have to change our limits as well. Our limits in terms of x are 2 and 0. In terms of u, it's just x plus 1. So our first limit will be 2 plus 1. That's 3. Our second limit is 0 plus 1. And that's equal to 1. And the hard work is done at this stage. So rewriting our original expression, our limits are now 3 and 1. X squared plus 2x plus 2 is u squared plus 1. X plus 1 is u, and dx is du. Now we can separate these fractions, because u goes into u squared, and you just get u, and u goes into 1, we get u over 1. And we do these individually, these two integrations. So integrate u, and we get u squared divided by 2, raised to the power by 1, and divide by the new power. The integral of 1 over u is natural log of u. And this is between the limits 3 and 1. So subbing in 3, we get 3 squared over 2 plus the natural log of 3 minus 1 squared over 2 minus the natural log of 1. And we might remember the natural log of 1 is 0. So that's an easy term to deal with. So neatening this up, 3 squared is 9, so that's 9 over 2. The natural log of 3. And 1 squared over 2 is just minus a half, minus 0. And 9 over 2 take away a half, that's 8 over 2, or 4. And we have natural log of 3. So 4 plus natural log of 3 is our answer. And that's our final example.